Welcome to AI Frontiers, Breakthroughs in Computational Linguistics. In this episode, we unpack 38 cutting-edge research papers published on August 14, 2025. Today's journey will explore the latest advances in language technology, spanning reliability, bias, and the future direction of AI. Featuring our paper of the day by Flores and colleagues, this episode is your guide to the evolving city of computational linguistics. Despite impressive achievements, today's most advanced language models can be stymied by simple obstacles. For example, a model that can write poetry or debate philosophy may falter when asked to recover from a missing email address or an ambiguous request. Even top-tier AI assistants can freeze if a required database suddenly goes offline mid-task. These real-world limitations reveal critical gaps in flexibility and adaptability. The latest research provides insights into these shortcomings and points towards solutions that may overcome them. Computational linguistics is the science of enabling computers to understand and use human language. This field underpins technologies such as translation apps, chatbots, and automated grading tools. By blending methods from computer science, linguistics, and psychology, computational linguistics empowers machines to reason, interact, and generate language in increasingly human-like ways. As these systems become more pervasive, understanding their strengths, weaknesses, and societal impact is essential for responsible deployment. Imagine computational linguistics as a bustling, ever-changing city. Foundational research ensures the city's infrastructure, robust and reliable language models, remains strong. Innovative work constructs new high-rises, introducing novel architectures and designs. Inclusion efforts add signs in many languages and create accessible pathways for diverse users. New neighborhoods, such as agentic behavior, bias auditing, and diffusion-based generation are rapidly emerging. This dynamic landscape is shaped by collaborative efforts across many domains. A major research theme centers on reliability and agentic behavior. As language models are integrated into real-world workflows, the question arises: can these AI agents adapt like skilled human navigators? Work by Flores and colleagues demonstrates that memory and planning can significantly enhance agent decision-making. Models are tested under scenarios where essential tools fail. Do they recover, or do they stall? Just as a GPS must reroute when roads close, AI agents require resilience. The technical concept of agentic behavior refers to autonomous action within complex contexts. Explainability and transparency are critical for the adoption and trustworthiness of neural networks. Recent papers, such as those by Smith and Lee, focus on building windows into AI reasoning. These tools equip teachers and policymakers to audit and debug AI decisions, making logic visible, much like a car dashboard. Interpretability fosters trust, safety, and accountability by clarifying opaque system processes. The technical goal of explainable AI is to provide clarity over black box decisions, ensuring humans can understand, trust, and, when necessary, intervene. Bias, fairness, and social impact constitute another central theme. The BIPOLAR framework by Zhang and colleagues maps political bias within language models, while researchers continue to develop methods for detecting and mitigating gender, racial, and social biases. These efforts are akin to city planners identifying and removing hidden hazards to ensure fairness in infrastructure. The overarching goal is to create technology that serves all communities, not just the most dominant voices. This approach is analogous to mapping microclimates rather than relying only on city-wide weather reports, revealing nuanced patterns and actionable insights. Research breakthroughs are best illustrated through mini-stories from the field. Flores and colleagues show that embedding memory and reflection in multi-agent systems leads to transformative accuracy improvements. Zhang's bipolar framework uncovers subtle, context-dependent biases in AI. Chen and collaborators reveal that most agents freeze when their tools fail, highlighting a lack of human-like resilience. Wang's work on diffusion models demonstrates accelerated text generation, likened to sculptors gradually refining their creations. Patel and colleagues expose safety gaps for younger users through the Sprout Bench benchmark, underscoring the need for age-appropriate safeguards. Our featured paper of the day, Towards Reliable Multi-Agent Systems for Marketing Applications via Reflection, Memory, and Planning, by U. Flores et al., addresses the challenge of building accurate customer lists for marketing, a task where mistakes can be costly. The RAMP framework mimics human cognition by enabling agents to plan, act, reflect, and remember. A dynamic memory base allows these agents to avoid repeating errors and adapt to new requirements. Iterative self-checking boosts recall, especially for ambiguous requests, and real business users report higher satisfaction when interacting with these AI systems. The RAMP framework operates through human-like iterative steps. The agent starts with a structured plan, mapping out the sequence of necessary actions. It consults APIs and external tools, gathering information through repeated cycles. After each step, the agent reflects on its outputs, verifies results, and, if required, reloops to refine its approach. A long-term memory module tracks facts, previous queries, and errors, preventing repeated mistakes. Technically, this approach is described as retrieval-augmented reasoning, where external knowledge is systematically consulted to improve decision quality. RAMP's impact is substantial. According to U. Flores and colleagues, the framework increases accuracy by 28 percentage points compared to standard planning agents. Its iterative verify and reflect mechanism elevates recall by approximately 20 points per round, especially for difficult or ambiguous queries. By embedding human-like self-critique and adaptability, RAMP demonstrates that memory and planning are not merely theoretical ideals, but practical tools. This blueprint paves the way for deploying reliable, trustworthy agents across business and broader applications. Looking forward, the field envisions a resilient city of language where AI systems can adapt to new dialects and languages with remarkable speed, much like skilled translators. Future agents will be capable of recovering from failures, improvising as needed, and explaining their reasoning in accessible terms. There is an increased emphasis on ethics, inclusivity, and interdisciplinary collaboration. As the city grows, new bridges will connect languages and people, transforming patchwork roadways into a robust global metropolis. In conclusion, the field of computational linguistics has evolved from parsing isolated sentences to enabling systems that reason, adapt, and engage in real-world scenarios. The work of U. Flores and others highlights the vital importance of memory, self-reflection, and fairness. The future trajectory points toward responsible, inclusive, and trustworthy language technologies. Listeners are encouraged to explore all 38 referenced papers for a deeper understanding and to actively participate in shaping the evolving city of language. The content for this episode was synthesized using GPT 4.1 from OpenAI, which created the narrative and summaries. TTS synthesis was provided by OpenAI, while visual suggestions were generated using Google Image Tools. A human expert reviewed the synthesized material to ensure clarity and accuracy. Some oversights may persist, therefore, consulting the original research papers is always recommended for comprehensive details. All referenced works, including those by U. Flores and Zhang, are provided for further exploration. Subscribe to AI Frontiers for in-depth explorations of the latest AI research and industry trends. Share your questions and insights. Your voice contributes to the ongoing journey. To find more episodes and the complete reference list, visit our channel online. Stay curious and join us at the next frontier. In this podcast, we bring you the latest breakthroughs in computer science and AI, straight from the archive preprint server. From neural networks to quantum computing, we simplify complex research so you can stay ahead. Whether you're a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thanks for listening. If you enjoyed this episode, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights. Disclaimer: this video uses content from the archive preprint server under its API terms of use. AI Frontiers is not affiliated with or endorsed by the archive preprint server.